This activity relates to direct variation. The objective of this activity is to verify experimentally direct variation using the first part, clock and craft paper, and second by using graph. So we'll be doing it through two different modes. Let's understand the concept. What is direct variation? So suppose there are two quantities X and Y, and you are trying to increase the X, that means the first quantity. Now, if on increasing X, Y also starts increasing by itself, then you call X and Y vary directly. Or if you decrease X, there should be a corresponding decrease in Y also. Then also we say that the two quantities X and Y vary directly. If you want an example, let's assume that there's an object which is moving from point P like this in this straight line. So as time increases, time of travel increases, the distance traveled also increases. So obviously the distance from P will keep on increasing as you increase the time. So we say that time and distance vary directly. There are innumerable examples of direct variation in day-to-day life. So we will be verifying direct variation in this activity, for which the material required are: we require a clock, a geometry box, pair of scissors for cutting work, graph paper. Obviously the second mode through which we will be verifying direct variation is the graph method, and glue for pasting work. Let's perform this activity now.
So in this activity on direct and inverse proportions, you can take a clock. I have taken a pic of a clock here showing that the minute hand is on 12. So you can do it actually using a clock by having a 3 o'clock in the clock, or a time of 4 o'clock, or a time of 5 o'clock, so that the minute hand is at 12. Now you need to observe the rotation of minute hand as time passes. So you will observe that after time is equal to 15 minutes, the angle covered, or the angle turned by this hand, which will now be at 3, is 90 degree. So the angle turned is 90 degree. Likewise, when it turns another 15 minutes, the time which elapsed is 30 minutes, and likewise after every 15 minutes you need to record the time like this. So it will be 15 minutes, 30 minutes, 45 minutes and 60 minutes, and the angle which it covers will be 15 minutes. After 15 minutes it will be 90 degree. After 30 minutes it will be exactly diagonally opposite like this, so covering an angle of 180 degree, likewise covering an angle of 270 degree, and covering an angle of 360 degree. So we all know that after 60 minutes the minute hand comes back to 12. Now if I take the ratio of this time and the angle turned, 15 upon 90 is 1 upon 6, 30 upon 180 is again 1 upon 6, 45 upon 270 is 1 upon 6, and 60 upon 360 is also 1 upon 6. So whenever the ratio of two quantities remains constant, then the two quantities are said to be in direct proportion. So the angle turned and the time passed, these two things, or the two quantities, are always in direct proportion. Now let's have another example where we are using a graph. You can see on this graph sheet we have drawn a 2 by 2 square. So in square 1, the length of the side is 2 centimeters, and therefore the perimeter will be 2 plus 2 plus 2 plus 2, 8 centimeters, and the area is 2 times 2, which is 4 centimeters square. Likewise, in the second square, you can see the length of side is 3 centimeters. In the next one it is 4 centimeters, and in the next one it is 5 centimeters. So you can find the perimeter now. This will be 12, this will be 16, this will be 20, And if you want to find the area, 3 square is 9, 4 square is 16, and 5 square is 25. Now we are trying to find the ratio of length and the perimeter. The length is 2 and the perimeter is 8. 2 upon 8 is 1 by 4. How about length and area? Length and area, 2 upon 4 is 1 by 2. Likewise, length and perimeter, 3 by 12 is 1 by 4. 4 by 16 is 1 by 4 and 5 by 20 is 1 by 4. Whereas 3 by 9 is 1 by 3, 4 by 16 is 1 by 4 and 5 by 25 is 1 by 5. Can you observe that this ratio remains the same, and therefore the length of the side and the perimeter of the square are in direct proportion. But what happens to the ratio L and A, the length of side and the area? The ratio is different, and therefore the length of side and the area are not in direct proportion. This is how you verify direct variation using this amazing activity.